Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 21st, 2025, about 5 days ago. It introduces a system called SketchVerify that plans motion using cheap video sketches, boosting instruction accuracy by about 11% and physical coherence by about 6%, while cutting planning time enough to reach nearly a 10 times efficiency gain. The paper is titled, Planning with Sketch-Guided Verification for Physics-Aware Video Generation. And as we will see later, the approach makes physics-aware video generation far more practical. So after that high-level summary, Figure 1 contrasts 3 ways to turn a text prompt and image into a video. The top left one-shot pipeline sends a single planned trajectory straight into the video generator, so any planning mistake persists. The top right iterative pipeline repeatedly regenerates full videos, which improves quality but wastes compute. The bottom SketchVerify pipeline instead generates many cheap video sketches, and a multimodal verifier selects a corrected, physically plausible trajectory before running the expensive generator once. Alright, the previous figure contrasted full pipelines, and Figure 2 now walks through how SketchVerify actually operates step by step. The left panel shows high-level planning, where a multimodal large language model planner breaks the prompt into sub-instructions and, with a segmenter, isolates moving objects and the clean background. The central panel illustrates test time planning, in which the planner samples many trajectories, renders fast video sketches, and a verifier scores each one. The rightmost strip shows the trajectory condition generator using the best plan to render a smooth, physically consistent final video. Well, Figure 3 zooms into how the verifier judges each candidate trajectory. The top image strip shows a robotic arm and a caret over several frames, paired with a sub-instruction that the arm should approach the caret. The multimodal verifier then splits its judgment into semantic checks, like whether the arm and caret appear and actually make contact, and physics checks like gravity, Newtonian motion, deformation, and penetration. These checks become separate scores that together decide whether the trajectory is acceptable. Alright, the previous figure unpacked how verification scores each trajectory, and Table 2 now shows how that strategy stacks up on the Phi-World Bench benchmark. The table reports pass rates for object and event correctness, physical standard realism, and an overall score. SketchVerify scores about 43 on object events, 24 on physical standard, and 20 overall, which together beat every baseline. Cosmos slightly edges it on object events alone, but loses clearly on physical realism and overall consistency. So while Table 2 focused on Phi-World Bench, Table 1 reports results on World Model Bench and highlights how strong SketchVerify is. The table shows that SketchVerify reaches the best instruction following score, about 2.1, and also tops every physics column and both common sense scores. These gains push the overall sum score to about 8.7. Crucially, SketchVerify does this with only about 5 minutes of planning, versus roughly 62 minutes for Phi T2 volts and over 1 minute for video MSG. So while Table 1 emphasized overall gains and planning time, Table 6 compares how different verification strategies trade quality for speed. The unverified baseline is fastest, but scores lowest on instruction following and physics. Generation-based verification slightly improves both scores, but needs about 39 minutes of planning. Sketch-based verification reaches the best physics score and nearly the best instruction score, while cutting plan time to only about 4 minutes, so it delivers the best quality per unit compute. So stepping back, 2 things stand out. Sketch-based verification lets motion planning become both more physically grounded and far cheaper. And it does so without any extra training, just smarter test time reasoning. That makes controllable, physics-aware video generation feel much closer to practical tools. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.